In lesson 10.3, we're looking at probability. Our answers will be between 0 and 1. So the probability that something is going to occur is going to be greater than or equal to 0 or less than or equal to 1. So our answers will be decimals, fractions, or written as percents. Probability, we have number of favorable outcomes over total number of outcomes. So we'll look at this example where we have starburst in an opaque candy jar. That means we can't see through the candy jar. We have 1 lemon, 4 blue raspberry, 2 watermelon, 2 tropical punch, and 3 orange. So our denominator says total number of outcomes. So the total number of outcomes for picking any starburst is going to be 12. And then we look, and do we have any cherry? We do not. So our favorable outcomes will be 0. So 0 over 12 is equal to 0. Let's look at the orange. So for orange, it says that we have 3 orange. So 3 over 12, that reduces to 1/4, which reduces to 0.25. The next one we're looking at is not strawberry. So not strawberry means we don't have any strawberry. So anything we choose is not going to be strawberry. So that's going to be 12 good choices over 12 total, which equals 1. And remember, it can be less than or equal to 1. Our last one we're looking at says we're going to pick tropical punch or lemon. Or means add. All right, so we have tropical punch. Tropical punch, we had 2 of those, so 2 over 12. And remember, we're adding. And lemon, we have 1 over 12, 3 over 12, which is equal to 1/4, which is equal to 0.25. So some key ideas that you need to make sure you have written down: the ratio for probability, the type of answers or the range of answers you can possibly get, and just remember that or means add. We still have the same kind of starburst in our opaque candy jar, but this time, what if we were selecting 2 starbursts at the same time? Now we're going to multiply our answers. So for instance, let's say we were picking blue raspberry. So blue raspberry, it says we have 4 blue raspberry. So I reach in, we have 4 blue raspberry, there's a total of 12. We said we're multiplying. Now we're down by 1 starburst because we didn't replace it, we took it out. And now because we add 4 blue raspberry, now there's going to be 3. We can simplify. 3 goes into 3 once, 3 into 12 is 4, and then we can simplify our 4 into 4 once. So our answer comes out to 1 over 11, which is 0.09. And we could write this as the probability of choosing blue raspberry times the probability of choosing blue raspberry. Okay, we're on to the lemon. We want to choose 2 starbursts and we want them both to be lemon. So we look, we have 1 lemon, so that's going to be 1 over 12. But unfortunately, that's all we have is 1 lemon. So we're down by 1 starburst in the jar. There's no possibility of choosing a lemon. So we're going to get an answer of 0. 1 times 0 is 0. Okay, now over to the orange. Orange and. So for and, remember we're multiplying. So orange, we have 3. So 3 over 12. We're multiplying. Watermelon, we have 2 watermelon. 2 over 11. We're going to go ahead and see if we can simplify. Goes in once, goes in 6. 3 goes into 3 once, but goes into 6 twice. So we're left with 1 over 22, which gives us 0.045. All right, let's look at something that's not a starburst. So we have a deck of cards. There's 52 cards in a deck, and we want to know the probability of choosing a black jack. We know we could have a club or we could have a spade. So there's 52 total. There are 2 choices, and that just reduces to 1 over 26. And you could change that to a decimal or a percent. How about choosing a 3? We could have a 3 of hearts, a 3 of diamonds, 3 of spades, 3 of clubs. So that would be 4 different kinds of 3s over 52, and that reduces to 1 over 13. Okay, way back in Algebra 1, we looked at geometric probability, and we learned that it's the ratio of lengths, areas, or volumes. So it's the area that's favorable over the total area is the example that we're going to look at. And I took this directly out of your textbook. So we want to find, all right, we're going to find the probability that we're going to get in the yellow circle, or get the 10 points. So the area of that yellow circle, pi r squared, and on the side here it says that the radius is 3, so pi 3 squared over, and then the total area includes this outside board, and it said 18, so that's 18 times 18, or 18 squared. That's going to reduce to 9 pi over 324 pi over 36, and that's going to be approximately equal to 0.0873. Okay, so in your notebook, make sure that you write down this for geometric probability. And we did areas, and it could be any kind of areas. We could be working with rectangles, squares, triangles. It could be lengths or volume as well. Last thing we're going to look at will be odds. When we're working with odds, it's just a restating of probability. People might say 1 and 2 or 5 and 7. So for instance, let's say someone said the odds of something occurring were 5 to 1. 5 to 1. The probability, so this is the odds, the probability would be 5 over 6. Okay, so let's look at that. The number of outcomes in A, so that's 5. Number of outcomes not in A, we have 1. Now, if we remember from probability, we have number of favorable outcomes, so 5. Total number of outcomes would be 6, because 5 and the 1 would give us the 6. Odds can be helpful when we want to compare how much larger one probability is relative to another. An event with probability, let's say, of 75% has odds of 75 to 25. So we can simplify that to 3 to 1. The event is 3 times more likely to occur than not occur. So that's just the difference between probability and odds.